You believe you're posing a simple question when you ask, what makes magnets push each other away? But you don't understand the nature of your own query. And until you see why the question itself is flawed, every answer you receive, including this one, will leave you feeling unsatisfied. Let me show you what I mean. Take two bar magnets and try to push their north poles together. Feel that invisible wall, that resistance hanging in the empty space between them. You want to know the reason. You want me to tell you that magnets repel for the same reason that, and then you want me to fill in that blank with something you already grasp, like a compressed spring or two hands shoving each other, something familiar. Here's the problem. There is no familiar analog, and I'm not being evasive or hiding behind jargon. I'm telling you the truth most people find hard to accept. Magnetic forces are fundamental. They are the bedrock of reality. There is nothing deeper to compare them to. You're asking me to explain the rules of the game by using something more basic than the game itself. But there isn't anything more basic. It's like trying to explain the concept of a number without using numbers. It can't be done. Now you're thinking, wait a minute, I've heard explanations. Magnetic fields, electron spin, quantum mechanics. Those sound like deeper reasons, don't they? They are not. They are descriptions. Incredibly precise, fantastically accurate descriptions of how the force behaves, not why it came to be. And you must grasp the critical difference between those two ideas, or this entire conversation is meaningless. Let me ask you something. Press your palm against the table in front of you. Go on, push down firmly. What stops your hand from passing right through it? Your first thought is, because the table is a solid object, and that's where the misunderstanding begins. It's not wrong because the table isn't solid. It is. It's wrong because solid is just a label, a different name for the very thing you're trying to explain. Try again. Why don't you merge with the table? Because the atoms are packed tightly together. Better. Keep going. Why don't the atoms in your hand pass through the atoms in the table? Because atoms are solid, too. No. Stop. Really think about this. Atoms are not solid. An atom is, for the most part, a vast emptiness. If you were to scale an atom up to the size of a grand cathedral, its nucleus would be a single grain of rice at the altar. The electrons would be motes of dust drifting in the distant pews. Everything in between is empty space. Your hand is essentially a cloud of nothingness. The table is essentially a cloud of nothingness. So why don't they just interpenetrate? You're starting to feel a sense of unease now. Good. You should be. The answer is electromagnetic repulsion between the electron clouds of your hand and the table. The electrons in your hand and the electrons in the table all carry a negative charge, like charges repel. So when you push down, what you're feeling is trillions upon trillions of tiny electromagnetic forces, all adding up to create the sensation you call solid. Now, here's the question that will truly unsettle you. Why do like charges repel? You can't answer that, can you? You can say, the electromagnetic force, but that's just giving it a name. That's not an explanation, it's a label. It's like asking, why do magnets repel? And answering, because of magnetism. That's circular reasoning. The electromagnetic force is one of the four fundamental forces of nature. It isn't caused by anything else. It isn't derived from something simpler. It simply is. And here's what nobody ever tells you. The force that stops your hand at the surface of that table is the exact same force that makes those magnets push apart. The same force. Not similar, not analogous, identical. So why does one feel completely normal and the other feel like a mystery? I'll tell you why. You've been pushing on solid objects since you were an infant. By the time you were a toddler, your brain had constructed an immense library of experiences pushing, grasping, falling, tumbling onto the ground. Your neural pathways wired themselves around these interactions, building patterns, expectations, a whole intuitive framework for how the world works. So now, when you push on a table, it feels obvious, natural, expected. You don't question it. You don't think it requires an explanation. But magnets push through a visible gap. You can slide a piece of paper between them. There's clearly nothing there. That feels strange. That feels like it needs an explanation. But here's the truth: the weirdness isn't in the physics, it's in your mind. When you press on the table, the electrons in your hand never actually touch the electrons in the table. They repel at a distance, a tiny distance, a few atomic widths, but a distance nonetheless. We call it contact, because the gap is too small for our eyes to resolve, but it isn't true contact. Nothing is ever touching. It is electromagnetic repulsion operating across a void. With the magnets, the void is simply larger, a centimeter, an inch, big enough to see, big enough to make you uncomfortable. But the force is the same. The mechanism is the same. The only difference is scale. The mystery you feel is not a mystery of physics, it's a mystery of psychology. You're comfortable with electromagnetic repulsion at microscopic scales because you've experienced it your whole life. You're uncomfortable with it at macroscopic scales because it's unfamiliar. That's it. That's the entire difference. You're probably thinking, all right, fine, but surely quantum mechanics explains why the electromagnetic force exists. It does not. Again, quantum electrodynamics, the quantum theory of electromagnetism, is the most precisely tested theory in the history of science. We've measured some of its predictions to 11 decimal places, and the theory matches reality perfectly. But here's what QED does. It tells you how to calculate electromagnetic interactions with breathtaking accuracy. It gives you the rules, the equations, the predictive power. What it does not do is tell you why the electromagnetic force exists in some deep philosophical sense. It describes the force beautifully, perfectly. But it doesn't explain it away in terms of something simpler, because there is nothing simpler. Let me show you how this works with a different puzzle. You ask, why does ice float on water? I can tell you it's because ice is less dense than liquid water. Why is it less dense? Because its molecules form a crystalline lattice with more space between them. Why that lattice? Because of the way hydrogen bonds arrange themselves at freezing temperatures. Why do hydrogen bonds behave that way? Because of the quantum properties of the electrons in water molecules. Why do electrons have those properties? Because of the Schrödinger equation and the Pauli exclusion principle. Why do those fundamental equations hold? Now you see what's happening. At each step, I'm giving you a deeper answer, but I'm also just pushing the question back one level. Eventually, and it happens fast, you hit bedrock. You hit the fundamental equations, the basic forces. And there, the only honest answer is that's what we observe. That's what the universe does. We can describe it with mathematics. We can test it with experiments. We can use it to build technology. But we can't explain it in terms of something more fundamental, because there isn't anything more fundamental. The chain of why has to end somewhere. Here is the deep problem with your question about magnets. When you ask, why, you aren't really seeking information. You're seeking reassurance. You're asking me to connect this unfamiliar phenomenon to something you already know so you can stop feeling confused. You want a story, a narrative chain of cause and effect that ends with something you intuitively grasp. But magnets repel because of the electromagnetic force. And the electromagnetic force exists because that is a fundamental property of our universe. There is no story. There is no deeper, because there is only measurement in mathematics. I know that isn't satisfying. I know you want more. But the cosmos is not obligated to provide an explanation that comforts you. The universe is what it is. What truly bothers me about this line of questioning is that you're treating magnets like they're some exotic exception in a world of normal things. That's completely backward. Everything is electromagnetic if you look closely enough. Why do chemicals react? Electromagnetic forces rearranging electrons. Why does light bounce off a mirror? An electromagnetic interaction. Why do you see colors? Electromagnetic radiation stimulating your retina. Why does the device you're listening to this on work? Electromagnetic forces moving electrons through its circuits. The electromagnetic force isn't some rare curiosity that only appears in magnets. It is everywhere. It is the dominant force in your entire existence. Gravity is weaker by a factor of 10,000 trillion trillion trillion. It's almost entirely irrelevant for atoms and molecules. The strong and weak nuclear forces are locked away inside atomic nuclei, too short range to affect anything you can directly touch. Everything else, and I mean everything, is electromagnetism. The force that makes magnets push apart is the same force holding your body together at this very moment. The same force preventing you from falling through your chair. The same force allowing you to process these words. So when you ask me to explain magnetic repulsion by comparing it to something normal, you're asking me to explain electromagnetism by using electromagnetism as the comparison. It's a logical loop. It can't be done. Let me try a different approach. Maybe this will help. You know how you could explain the taste of salt to someone who has tasted it before? You just say, it's like salty pretzels or sea water. You give them examples. But how would you explain the taste of salt to someone who has never experienced it? You could talk about sodium chloride ions, about how they bind to specific protein receptors on your tongue. You could give them all the biochemistry of salt. But none of that conveys the actual sensory experience. They have to taste it. There's no shortcut. It's the same with magnets. It's the same with fundamental forces. You don't gain a true intuition from a clever analogy. You don't get it from a 5-minute explanation. You have to work with the mathematics. You have to solve the problems, make the calculations, and test the predictions. After months, maybe years, of wrestling with electromagnetic theory, something shifts in your mind. The equations start to feel natural, intuitive, obvious, not because they match your everyday experience, but because you've built a new everyday experience. A mathematical experience. An experience with how fields and forces truly behave. And then magnets are no longer mysterious. They are exactly what the equations predict they would be. They are the inevitable consequence of charged particles and fields. But you cannot shortcut that process. You cannot skip to the end. You have to earn the intuition. So, what can I give you? I can give you the technical answer. Magnets have magnetic dipole moments. Tiny, intrinsic arrows of magnetism. When you align vast numbers of these in the same direction, you get a permanent magnet. Those dipoles generate a magnetic field that stores potential energy. All physical systems naturally evolve toward their lowest possible energy state. When two north poles face each other, the field configuration is high energy. Moving them apart lowers that energy, so they repel. That's the answer. That's as deep as the rabbit hole goes. You want to know why dipoles create fields? I can tell you about moving charges and electrons spin. You want to know why electrons have spin? I can tell you about the Dirac equation and the principles of quantum mechanics. You want to know why the Dirac equation is correct? I can tell you it arises from combining special relativity with quantum theory. You want to know why those theories hold? Because they describe reality. Because we have tested them millions of times and they work. Every single time. That's it. That's where the chain ends. Here's what you need to understand about how physics actually functions. We don't start with philosophy and derive the universe. We start with observations. We see patterns. We write equations that describe those patterns. We test those equations against new experiments. When the equations work, when they let us predict things we haven't yet seen, we say we understand the phenomenon. Understanding in physics doesn't mean philosophical comfort. It doesn't mean matching your intuition. It means predictive power. It means being able to calculate, to forecast, to build technology that functions. By that standard, we understand electromagnetism better than almost anything else. Quantum electrodynamics is tested to an almost unimaginable degree of precision. So when I say I understand magnets, I mean this: I can calculate the force between them. I can predict their behavior in any configuration. I can design electric motors, generators, MRI machines. I can manipulate magnetic fields to contain plasma or focus particle beams. That is real understanding. That is what physics offers. Not comfort, not familiar stories, but power. The power to describe and control nature. You might not like this answer. You might find it deeply unsatisfying. Tough. The universe doesn't owe you an explanation that makes you feel cozy. It doesn't owe you a narrative that fits your preconceived notions of how things ought to work. Your intuition evolved to help you throw rocks, find food, and avoid predators on the African savanna. It did not evolve to comprehend quantum fields or the nature of reality at the subatomic scale. So when physics reveals something that violates that intuition, particles behaving like waves, time dilating at high speeds, magnets pushing through an apparent void, you have two choices. You can reject it as mysterious and unsatisfying and keep demanding a simpler explanation that doesn't exist. Or you can expand your intuition. You can learn the mathematics. You can work through the problems. You can build new mental models based on equations and experiments, not on everyday experience. That is what physicists do. None of us found quantum mechanics intuitive at first, but we worked with it long enough that it became familiar, and eventually, it started to feel natural. Not because it conformed to common sense, but because we built a new common sense, a mathematical common sense. So here is what I want you to take away from all this. The next time you pick up two magnets and feel that invisible push between them, don't ask why. Ask how. How does the force change with distance? How strong is it compared to gravity? How can I calculate it? How can I use it? Those questions have answers. Good answers, precise answers, beautiful answers. The why question, the one that demands a reduction to something more familiar, that question has no answer. Not for magnets, not for any of the fundamental forces, because fundamental means exactly that, the bottom level. There is nothing underneath. But here is the beautiful thing that people miss when they get stuck on why. What physics reveals is that the entire universe operates according to a surprisingly small set of rules. The same equations that describe magnets also describe lightning, the signals in your brain, the computer chips in your phone, the aurora borealis, the chemical bonds that hold molecules together, the reason stars shine, the reason atoms themselves are stable. That is not a failure to explain. That is unification. That is the discovery that underneath all the apparent complexity and chaos of nature, there is a deep and elegant structure. A mathematical structure. Simple rules with breathtakingly complex consequences. That's what should truly blow your mind. Not that we can't reduce magnets to something simpler, but that we can reduce thousands of seemingly unrelated phenomena to the very same underlying force. You wanted me to explain magnets by comparing them to something familiar. But I'm telling you something far more profound. Everything familiar is, at its core, an expression of that same force. Your desk, your body, the air you breathe, the light you see, chemistry itself, life. It is all just different arrangements of electromagnetic interactions. You are not separate from the magnets. You are made of the same stuff. You are made of the same force. So, was my refusal to play along with that TV reporter arrogant? No, it was honest. I could have given him a comfortable fiction. Magnets are like tiny invisible springs. Or, imagine magnetic fields are like rubber sheets. He would have nodded and felt satisfied, and he would have learned absolutely nothing. Instead, I told him the truth. The question itself was based on a false premise. The kind of why he was looking for doesn't exist at the fundamental level. Things just are, and our job as scientists is not to reduce them to something more comfortable, but to describe them as accurately as possible. People hated that answer. They called it evasive, a failure to communicate. But they were wrong. Sometimes the most honest answer is, the universe doesn't operate the way you expect it to. Your intuition is incomplete. And if you truly want to understand what's happening, you need to learn a new way of thinking. That isn't arrogance. That's respect. Respect for the truth. Respect for the actual structure of reality. And respect for you, for your ability to handle that truth instead of settling for a comforting lie. So pick up those magnets one more time. Feel that invisible push. Now understand that you are feeling one of the four fundamental forces of nature. The same force that makes all of chemistry possible. The same force that allows stars to burn. The same force that is holding your body together right now. That's not mysterious. That's magnificent. And the fact that we can describe it with equations, test it with experiments, and use it to build the modern world, that isn't a failure to explain. That is what understanding truly looks like.